Elon Musk might never highlight them on stage. These hidden foundations are what make the Tesla Model 2 not just a budget EV, but a trustworthy daily companion. Beneath the sleek design lies small, overlooked technologies that quietly define how this car thinks, senses, and lasts. To truly appreciate what makes the Model 2 unique, you have to look past the big promises and understand how these invisible systems work together to create something that feels alive, self-maintaining, and enduring. The Model 2's intelligence begins deep inside its battery. Unlike most electric cars that simply monitor voltage and temperature, the Model 2 is designed to anticipate changes before they become problems. Its advanced battery management system learns your charging habits, driving style, and the thermal history of every cell cluster. By analyzing this data, it can detect when one small group of cells starts drifting out of sync with the rest. When that happens, the car automatically redistributes current, unloads weaker cells, and rebalances them during the next charge cycle. This proactive balancing keeps cell resistance uniform and prevents long-term degradation. In testing, early intervention can bring cell spread back under a 3% threshold, which translates into years of stable charging and consistent performance. The car doesn't just predict, it also regulates temperature intelligently. Traditional EVs treat the battery as one massive block, meaning a single overheated corner can stress the entire pack. Tesla's zone thermal control divides the pack into microzones, each with its own heat exchange lines and microvalves. When one zone heats up under heavy load, it receives targeted cooling, while colder regions get gentle preheating. Maintaining a temperature delta under 5 degrees Celsius dramatically slows aging since chemical, where it roughly doubles with each 10-degree rise. This is why, after years of use, the Model 2's 10 to 80% charging time might increase only slightly, from 28 to around 31 minutes, showing how little its performance drifts over time. In winter, zone preheating keeps range loss to roughly 20%, compared with 30% or more in typical mass-market EVs. Instead of wasting energy warming the entire battery, it heats only what's needed, so the car launches smoothly even on freezing mornings. Together, these systems make the Model 2 feel like it takes care of itself. The payoff is not only technical stability, but also financial savings. Steadier charging patterns allow predictable off-peak electricity use, potentially saving households hundreds per year while reducing stress and improving safety in cold conditions. The Model 2 also seems to hear the world in ways humans cannot. Its body is lined with a dense array of accelerometers and strain sensors that detect micro-vibrations throughout the chassis and suspension. These sensors pick up patterns far below human perception, creating a vibration fingerprint unique to each car. By comparing these fingerprints with data from thousands of other vehicles, the Model 2 can identify anomalies that hint at early mechanical wear. When vibration amplitude in a specific frequency band rises significantly, the car doesn't just flash a vague warning. It suggests specific checks, such as verifying torque on a suspension link or inspecting a wheel bearing. Early intervention like this can turn what would have become an expensive repair into a simple tightening job. Over time, this predictive sensing sharply reduces failure rates. Minor faults per 100,000 kilometers could fall from a dozen to about 5, while roadside breakdowns nearly vanish. The car's silent awareness creates a sense of effortless reliability. Most owners may never realize how many issues their car prevented before they could even be heard or felt. Another quiet innovation lies in how the Model 2 keeps electrical power steady. Every electric car depends on thousands of connections linking cells, modules, and control circuits. Over time, repeated heating and cooling make metals expand and contract, loosening these contacts and allowing thin oxide layers to form. Even a few micrometers of oxidation can raise resistance by 20%, wasting energy and generating extra heat that accelerates wear. Tesla's solution involves connectors that automatically adjust their clamping pressure. Using tiny elastic or actuator-based mechanisms, they sense micro-voltage drops or local temperature spikes and apply a small compensating force, only a few newtons, to restore tight contact. Maintaining a pressure around 10 to 15 newtons per square millimeter keeps resistance nearly constant through thousands of cycles, equating to nearly a decade of stable use. The result is smooth, consistent power delivery. The car powers up instantly, Auxiliary systems run reliably in heat or cold, and electrical glitches become rare. Statistically, connectors with this technology show about 40% fewer faults after 3 years, improving efficiency by up to 3% across countless charge cycles. What feels like seamless reliability on the surface is actually precision engineering at work behind the scenes, keeping the Model 2's electronics clean, cool, and dependable for years. The final piece of the puzzle is how the Model 2 guards its signals in a world full of electromagnetic noise. Today's EVs carry hundreds of sensors and modules, exchanging data in real time. High-power charging in dense urban radio environments can easily inject interference, confusing sensors and corrupting readings. Tesla's engineers reportedly built a fine conductive mesh, a miniature Faraday cage, around critical circuits. This shielding not only blocks external interference, but also absorbs and grounds internal noise. Control modules rest on independent grounding planes to prevent stray currents from spreading across the chassis. The outcome is clear, stable data even when charging at 250 kilowatts or driving near powerful transmitters. With less than 0.5% signal error in high-noise scenarios, compared to the 2 to 3% typical in other EVs, the Model 2's driver assistance feels smoother and more precise. Sensors maintain consistent readings, BMS communication stays accurate, and even under heavy load, voltage differences between modules remain under 0.02 volts. Drivers experience this as seamless operation. No flickering warnings, no camera dropouts, no sudden ADAS disengagements. What's really happening is that the car filters chaos into calm, protecting every layer of its intelligence. Together, these hidden systems reveal the real spirit of the Tesla Model 2. It predicts problems before they happen, listens to its own body to stay precise, preserves energy flow year after year, and shields its nervous system from interference. None of these details shout for attention, yet they define how the Model 2 transforms affordability into lasting quality. It is not just a cheaper Tesla. It is a smarter, more self-sustaining one. Each drive, each charge, and each season proves that intelligence is not always visible. Sometimes it lives quietly inside the machine, ensuring that what feels simple and stable to you is actually the result of deep, invisible complexity. If you've made it this far, you now understand why the Model 2 is not just another EV. It is a glimpse of how technology can make reliability itself intelligent. And that may be Tesla's greatest secret.